Hi everyone, welcome back. Today we're talking about physics, not the kind you've heard 1,000 times. Today I want to offer you something different, a framework in which black holes are not what you've always been told they are, in which the Big Bang is not a beginning, in which matter never dies, and in which every major paradox haunting modern physics, every single one, doesn't get solved. It dissolves, like fog when the sun comes up. I know what you're thinking, big claim, and you're right to be skeptical. Theories of everything that promise miracles are everywhere, and almost all of them end up in the drawer labeled alternative physics. So let me say this up front. What I'm describing today is falsifiable. It makes specific, numerical, measurable predictions. If the data contradict them, the theory is wrong. That's the only criterion that matters in physics. Let's start at the beginning, with a word nobody ever stops to question. When you hear the Big Bang originated from a state of infinite density, the word you should pause on is infinite. In mathematics, infinity is a tool. In physics, infinity appearing in an equation is almost always a warning sign. It means the theory has hit its limit, that the equations are no longer describing reality, they're describing themselves breaking down. A gravitational singularity with infinite density and zero volume is not a physical object. It's the point where the theory stops making predictions and throws its hands up. Modern physics has built an enormous and largely functional structure around that surrender, with corrections, additions, hypothetical entities introduced to patch what doesn't work. Dark matter, because galaxies rotate the wrong way. Dark energy, because the universe is accelerating and shouldn't be. Cosmic inflation, because the microwave background is too uniform to be explained by a simple Big Bang. Every problem generated an ad hoc solution. Every solution introduced new physics that has never been directly observed. I'm not saying standard physics is wrong. I'm saying it looks like something that works despite its foundations. And when a theory keeps needing patches to stay standing, the problem usually isn't the patches, it's the foundations. Common relativity starts there. It doesn't add anything, it removes things. To understand how, we need to talk about neutron stars. A neutron star is the collapsed core of a massive star, compressed into an object 10 to 15 kilometers across with a mass 1 to 3 times that of the Sun. The density is physically obscene. What prevents this structure from collapsing further is the Pauli exclusion principle, one of the pillars of quantum mechanics, which essentially says neutrons cannot be forced into the same quantum state in the same place. They physically refuse to get too close. They push back. That pushback is called degeneracy pressure. Now, what happens if this star keeps accreting? If it captures matter for millions of years, billions of years? The standard model says it crosses the Tolman-Oppenheimer-Volkoff limit, around 2 or 3 solar masses. Degeneracy pressure fails, and the star collapses into a black hole with a singularity at the center. Common relativity says something fundamentally different. And the difference starts with how you interpret the TOV limit itself. In the standard picture, crossing that limit means degeneracy pressure loses to gravity and the star collapses. In this model, nothing of the sort happens. Pauli pressure doesn't fail. It doesn't get overcome. It keeps doing exactly what it has always done, holding the fermionic structure of the star together. What changes at the top limit is something completely different and far more subtle. The photons emitted from the star's surface, carrying away energy, heat, information, progressively lose their ability to transfer that energy to a distant observer. To climb out of a deep gravitational well, a photon must spend energy. The more compact the star, the more energy it spends. At the top limit, the star reaches a compactness at which the fraction of energy a photon can actually deliver to a faraway observer tends to zero. The photon leaves, but arrives empty. The signal dies. The star goes silent. It's not a collapse. It's a silence. The internal structure is intact. The neutrons are still there. Pauli pressure is working perfectly. Matter is organized exactly as before. But nothing reaches the outside anymore. The object becomes invisible, not because it's dead, but because the communication channel with the external universe has closed. What we call a black hole is this: a fermionic neutron star, structurally intact, hidden behind an impenetrable energy veil. And that star, invisible and silent, keeps accreting. It captures matter year after year, millennium after millennium, on cosmic timescales that dwarf anything we can directly observe. It grows in silence until it approaches a second limit, enormously far from the first, of completely different nature, having nothing to do with optics but with the quantum structure of matter at the most extreme thresholds of physics. It's at that second limit that matter can no longer compress, that collapse stops, and that a bounce occurs. That ceiling has a name, Xi. Xo is the maximum aggregation constant, the Pilotta limit. Its value is on the order of 3 times 10 to the 54th kilograms, roughly 1 billion solar masses. But the precise value matters less than something extraordinary about how this number arises. Xo is not a parameter inserted by hand into the theory. It wasn't chosen to make the numbers work. It's a constant that emerges, independently, from 10 distinct derivations, each starting from completely different physical assumptions and all arriving at the same order of magnitude. This doesn't happen by accident. In the history of physics, a constant that converges from 10 independent paths is the strongest possible signal that it describes something real. Let's go through them, because they deserve to be named. The first comes from the Tolman-Oppenheimer-Volkoff equations themselves, describing the hydrostatic equilibrium of a neutron star. When the internal curvature conditions are correctly included, the solution shows a stable upper limit on aggregable mass. That limit is Xi. The second comes from the internal geometry of Schwarzschild. Treating the internal dynamics of an object beyond its own horizon with regular boundary conditions, without presupposing a singularity, shows that curvature reaches a finite, well-defined maximum. The mass value corresponding to that maximum is Xi. The third comes from quantum statistical mechanics applied to a zero-temperature Fermi gas. The degeneracy pressure of ultra-degenerate neutrons grows with density according to a precise law. The direct calculation of the point beyond which no fermionic pressure can sustain the system gives a critical mass of the order of Xi. The fourth comes from observational cosmology. Considering the mass aggregable on cosmological scales, the effective baryonic fraction, the hierarchical structure of aggregations, the total mass required for a cosmic bounce converges on the same number. The fifth is perhaps the most elegant. It works backwards, starting from the cosmological constant lambda, measured with precision from observational data, and imposing that lambda represents the thermodynamic memory of a bounce, as this model claims, Xi is recovered by inverse inference. The relation is exact. Xi equals c to the fifth power divided by the reduced Planck constant, times g squared, times the vacuum energy density. The number that comes out is the same. The sixth comes from analysis of the cosmos's structural hierarchy. Studying how gravitational evolution tends to maximize aggregable mass through successive mergers, the upper limit on mass accumulation in an isolated causal domain coincides with Xi. The seventh starts from the Pauli limit combined with global metric coherence, imposing that the obscured fermionic domain at plateau density be compatible with the matrix coherence scale across the entire volume of the cosmos, yields an implicit equation for Xi with the same solution. The eighth is an energetic derivation of the bounce. Computing the critical curvature at the moment of the bounce and the total energy of the system at that threshold, the cosmic coherence constraint produces Xi again. The ninth comes from the thermodynamics of fields on cosmic scales, applying the Bekenstein bound, the upper limit on the entropy of a physical system, to the entire causal domain at the moment of the bounce. The compatibility between the maximum entropy of the fermionic content at Pauli saturation and the global entropic bound imposes a minimum radius and a critical mass that converge on Xi. The 10th comes from an informational functional on absolute cosmic time, defining a measure of the quantity of quantized time contained in the cosmic domain, built from the causal resolution imposed by quantum mechanics. The maximum value of this functional, compatible with the structure of cosmic time T0, produces the same critical mass once again. 10 derivations, 10 paths, starting from completely different places: geometry, quantum mechanics, thermodynamics, observational cosmology, information theory, all arriving at the same number. This kind of convergence is exactly what has always preceded the recognition in the history of physics that a constant is structural in the same way C, G, and the Planck constant are. Think about how C works. It's not that at some velocity someone put up a stop sign. The structure of space-time itself makes it impossible to exceed. Inertial mass grows, time dilates, space contracts, and C stays forever out of reach. Not by decree, by geometry. Xi works the same way for gravitational mass. It's the limit beyond which the fermionic structure of matter and the geometry of gravity together leave no room to continue. When an obscured star reaches Xi, the accumulated repulsive pressure finds a release. The quantum vacuum structure locally destabilizes. There is a phase transition of the vacuum itself, from a metastable state to a more stable one, releasing enormous energy, enough for a Big Bang. A new bubble of space-time forms, a new universe. And this is where we reach the most important distinction in this entire episode, one that science communication almost always ignores, collapsing two radically different things into one. Universe and cosmos are not synonyms. The universe, the one we live in, is a bubble. The causal domain that expanded from our Big Bang. It has its galaxies, its stars, its operational physical laws, its cosmological horizon beyond which we cannot see. It's vast, almost incomprehensibly vast, but it's a bubble. The cosmos is the total container, the set of all bubbles. Every universe born from every bounce that has occurred, is occurring, will occur. The cosmos was not born with our Big Bang. It is not bounded by our horizon. It's the background structure in which bubble universes exist and interact at scales that go beyond the internal causality of any individual one. This distinction isn't poetic. It's physically necessary to understand how the bounce works. Because Xe is a large number, but it's not infinite. And the total mass of our observable universe is estimated at around 10 to the 53rd kilograms, about 30 times less than Xe. Our universe, by itself, does not contain enough matter to reach the maximum aggregation limit. No single galaxy gets there. No galaxy cluster. No structure contained within a single bubble universe comes anywhere close to Xe. This means the bounce that generated our universe was not produced by a single previous universe. There is no parent universe we were born from. There is the cosmos, this structure larger and older than any single bubble, in which matter from multiple different universes, through cosmic gravitational dynamics, can converge and concentrate. When this transuniversal aggregation reaches Xe, the bounce occurs. A new universe is born, not as the child of one, but as the product of the distributed contribution of many. The true originary event is hierarchical, distributed, transuniversal. Our Big Bang is not the beginning of everything. It is the end of an aggregation process that involved matter from many different universes, converging in the cosmos until it reached its structural limit, and then exploding into a new bubble. We are not children of a universe. We are children of the cosmos. Now we need to talk about time, because without this piece, the model doesn't stand up. Modern physics has two descriptions of time that are not compatible with each other. Newton had absolute time, a universal clock ticking equally for everyone, everywhere, regardless of anything. Einstein showed this isn't true. Time is local. It depends on the observer's velocity and the strength of the gravitational field. Two clocks in different positions in the universe measure time differently. That's not an illusion. It's physics. The problem is that quantum mechanics, the Standard Model, and thermodynamics all operate with a time that flows forward for everyone, with an arrow of time defined by the increase of entropy on cosmic scales. And general relativity produces regions where time stops, reverses, or loses meaning, inside black holes, near singularities. These two descriptions are not reconciled. There is no coherent theory today that unifies quantum time with relativistic time. It's one of the deepest open problems in physics. Common relativity introduces a third way. Cosmic time, written T00, is neither Newton's absolute time nor Einstein's local time. It's a real, physical, measurable scalar field that globally orders all events in the universe. It's not locally homogeneous. Relativistic time dilations exist. They're real. Clocks in different situations measure different times. But these are all local distortions relative to a background parameter that never stops, never reverses, and guarantees globally coherent causal ordering. What is the physical basis of this cosmic time? Entropy. The entropy of the universe increases monotonically on cosmic scales. This is the most robust fact we have about the direction of time. It's not a local law, it's a global property of the system. And this monotonic growth of cosmic entropy is the operational indicator of cosmic time T0. Every observer, wherever they are and at whatever speed they move, can in principle refer to this parameter and synchronize their evolution with that of the universe. This single change, introducing a physical global time instead of treating local temporal coordinates as if they were the reality of time, resolves in one move a series of problems that modern physics has accumulated over decades. Temporal singularities vanish because T0 has no singularities. Time travel is impossible because T0 is monotonic. Causality is guaranteed globally, not just locally. Schrödinger's cat is never in macroscopic superposition because the physical state is unique at cosmic time. The wave function describes our ignorance, not a doubled reality. Now we reach what I find most compelling about this framework. Modern physics has a collection of unsolved problems that have become so familiar they seem normal. We almost take them for granted, as if they were an inevitable part of the complexity of nature. Dark matter, that mysterious substance that supposedly emits no light, interacts with nothing except gravity, makes up 27% of the universe's energy content, and of which we have never directly detected a single particle. Dark energy, that exotic fluid that supposedly pervades space uniformly, has negative pressure, causes the acceleration of cosmic expansion, and constitutes 68% of the universe, without anyone ever understanding what it actually is. Cosmic inflation, that period of exponential expansion in the first instance after the Big Bang, introduced to explain why the universe is so uniform and flat, requiring the postulation of an inflaton field never observed. The black hole information paradox. If matter falls into a black hole and Hawking is right about evaporation, information is destroyed, which violates quantum mechanics, and nobody knows how to get out of that corner. Singularities. Those points where equations blow up, which nobody believes are physically real, but nobody knows how to cleanly eliminate. These are not mysteries of nature, they are modeling errors. Dark matter arises from the assumption that visible mass, the mass that emits light, is the only source of gravitational curvature. In a model where black holes contain real, dense fermionic matter that emits no radiation, but curves spacetime, the difference between visible mass and gravitational mass doesn't require inventing new particles. It requires stopping the confusion between a photograph and an energy budget. Dark matter is not a mysterious substance. It's the fermionic matter of compact objects you can't see, but that is physically there. Dark energy is the structural memory of the bounce. The cosmological constant lambda, the term Einstein introduced, then withdrew, then was reintroduced to explain cosmic acceleration, is not a fundamental constant to be postulated. In this model, it derives directly from Xi. The relation is precise. The vacuum energy density equals C to the fifth power divided by the reduced Planck constant times G squared times Xi. Lambda is not a free parameter. It's a consequence of the maximum aggregation limit. It's the imprint the bounce left on the structure of our universe. Cosmic inflation is redundant because the bounce solves the problems inflation was invented to address. The homogeneity and flatness of the cosmic microwave background are naturally explained if the universe was born from a transuniversal aggregation process, in which initial conditions were already distributed across enormous scales. You don't need the first instance of exponential expansion. You need the conditions inherited from the process that preceded the Big Bang. The information paradox disappears because matter falling into a black hole is never destroyed. It remains there, compressed in the fermionic structure of the obscured star, and when the bounce occurs at the limit Xi, all that information transits into the new bubble universe that forms. Information is not lost, it changes address. Singularities are physically impossible because Xi is a real structural limit, not a mathematical threshold. The repulsive pressure that emerges near the Planck threshold can never be overcome by gravity. Density cannot diverge. Collapse always stops before producing a physical infinity. Schrödinger's cat was never in macroscopic superposition. The physical state of the system is unique at cosmic time T0. The wave function describing its two possibilities was a representation of our ignorance, an epistemic tool, not an ontological description of a doubled reality. The coherence operates on timescales enormously shorter than our ability to observe, and the cat is alive or dead long before we open the box. See what's happening? This isn't solving one paradox at a time by introducing a correction for each problem. It's changing the underlying ontology, the description of what physically exists, and the paradoxes stop arising. These aren't new explanations. This is not committing the errors that generated them in the first place. Paradoxes don't get solved because they have no physical structure to solve. They dissolve when the error that generated them is removed. A coherent theory doesn't produce monsters. Common relativity might be wrong, but it will never produce singularities, instantaneous collapses, action at a distance, invented energies, or parallel universes as narrative excuses. Because it cleanly separates mathematics from reality, imposes concrete physical limits, uses a real global time, and treats matter as the primary entity, not as a side effect of geometry. Which brings us back to where we started, falsifiability. A theory that makes no verifiable predictions is philosophy, not physics. Common relativity makes 4 specific measurable predictions. It's worth noting that 4 precise falsifiable predictions already exceeds what many mainstream frameworks explicitly offer, models that sometimes limit themselves to reproducing existing data without exposing themselves to future tests. First, no compact object in the observable universe exceeds the limit xi. If the Event Horizon Telescope, or LIGO, detected an object violating this ceiling, the theory is falsified. No appeal. Second, the cosmic microwave background must show specific anomalies at large angular scales, the low multipoles, the ones corresponding to the largest structures on the sky. These anomalies are incompatible with the standard lambda CDM model, but compatible with structures inherited from a transuniversal bounce. This is not a post-hoc prediction. The anomalies are already there. Planck measured them. The open debate is whether they are instrumental systematics or real physics. CMBS4 can settle it. Third, primordial non-Gaussianity. Small deviations from a Gaussian distribution in the cosmic microwave background fluctuations must have a specific value, f_NL around -5. This number is not freely chosen. It emerges from the structure of the transuniversal bounce. The Euclid telescope, currently in orbit, has measurement of this parameter among its primary scientific objectives. If the measured value deviates significantly, the theory is in trouble. Fourth, no future experiment will find dark matter particles. Not because the dark matter phenomenon doesn't exist. The difference between visible mass and gravitational mass is real and observed, but because that difference is explained by the fermionic matter compressed inside compact objects, not by exotic new particles. If the LHC or any underground direct detection experiment found a dark matter particle with a defined mass and cross-section, the theory would be falsified. 4 predictions, 4 tests. Any one of them contradicted by robust data and the theory falls. That is how physics is supposed to work. So, to recap, black holes are not ontologically distinct objects from neutron stars. They are the same fermionic structure in a regime of gravitational obscurement, the same matter, always, at every stage, never a singularity. The limit xi is a real structural ceiling on maximum aggregation, playing the same role for gravitational mass that the speed of light plays for velocities. The cosmos is the total container, far larger and older than any single universe. Our universe is not the child of a predecessor. It was born from the transuniversal aggregation of matter from multiple bubbles in the cosmos, when that concentration reached xi. Cosmic time T0 is a real physical scalar field that globally orders causality, grounded in the monotonic growth of cosmic entropy. And all the major paradoxes of modern physics, dark matter, dark energy, inflation, singularities, the information paradox, Schrödinger's cat, are not mysteries of nature. They are consequences of specific ontological errors that this model does not commit. Nothing ends. Nothing is destroyed. Matter continues, transforms, bounces, generates. See you next episode.